Welcome back to AK Logics. In the previous class, we have discussed about the integer data type. Okay, so in this class, we're going to discuss about the time data type. So the time data type, we have two types of time data types. One is time itself, and other is real time. Okay, time variable is unsigned 64-bit wide and can be used to store simulation time quantities for debugging purpose. A real-time variable simply stores time as a floating point quantity. Okay, so actually we have two types, right? Time is two types. Time data type is divided into two types. Two types. Two types, namely time and real time. Okay, yeah. So this is the syntax: time followed by the variable name, real time followed by the real variable name. And time can be stored at a time value like 50 nanoseconds, whereas R time can able to store the time like 40.25 picoseconds like this. It means simply time is used to store the integer values itself in the integer time values, whereas real time is used to store the real values. It means floating point values. Okay, so let me and also we have to see all these things, right? Let me bring this. Let me bring this. These are the points we have to observe. Okay, let me let us observe. Okay, so we paste over here. So for this, let us see first for the time. Okay, so let me create a module, time data type. Okay, and I'm going to declare the time. Similarly, I'm going to declare the end time. Okay, end time, and I haven't mentioning any, and I'm not giving any value to it. Okay, so again initial begin, and let me use the dollar display statement. So end time is equal to percentage. What we have to use over here? Tell me what we have to use over here. We can able to use the percentage 0d or any other format space where we have to use. So let's see. First we have to use the percentage 0d. Let's see whether we're gonna get this value or not. So I have used the percentage 0d means, so it's a time is a integer used to store the integer time values, right? So I have used the percentage 0d. If it's going to be stored the floating point, I'm going to use the percentage 0f. Let's see whether it's wrong, cut or wrong. Yeah, okay, yeah, the coding is always doing mistakes and learning. Okay, that's it. So by this code, what we gonna get? We're gonna get how much the default size of the time and the default value of time also. Okay, let me clear this program which is previous integer data type. Okay, yeah, let me run this program again. So yeah, gonna get the end time equal to x, end time equal to x. Let me remove this 0 and print over again. So you didn't get anything, you get the value x. Okay, you get the value x. Okay, so actually we have to use the percentage 0 b, right, to know the number of bits it going to be stored. Okay, you have to use the percentage 0 b. Yeah, I forgot it. So I am thinking why we are getting the only single value like that. So let me print this. So if you're gonna see total 64 access will be there. Okay, total 64x will be there. So total 64x's, you count it, you will get 64. Okay, it means we can able to say that time, sorry, uh, can store. Okay, it will store, right? Variables always store. Okay, time can store 64 bit by default. Okay, so let me change in all this. Okay, they don't carry, they store, only the wire will carry, right? So yeah, so if you're gonna think, and the time default value is x. Okay, why the time default value is x means it's going to print 64x, right? It means we haven't assigned anything, right? So it's going to print 64x. Okay, and by default time is signed, there will be no any negative time, right? Unsigned, time is unsigned. By default time is uh, unsigned. Why? Because there will be no any negative time, right? So unsigned. Let us see this also what happens. Let's see. Okay, so let me assign a time first equal to 50. Okay, so let me print this. Let me use the percentage 0d. Okay, 50. Okay, we got the 50. So let me use 50 point some 25. Okay, let's see what will be the value. Okay, we got the 50. It is discarding the value, right? So next, let us store some negative time. Okay, negative time in the sense minus 50. Okay, yeah. Let's see what will be the value. So we are getting the this particular value. How we gonna get this particular value? So let us put signed over here because time is unsigned, so that we are getting the 2's complement positive number of minus 50. Okay, it means what we are getting uh, when we use unsigned, when we use minus 50, we are getting 2 power 64 minus 50. Okay, so let me print again by saving this code. Let us see whether we are getting the, so we are getting minus 50. Okay, so let me explain this point. Okay, so let me explain that point. So by default time is unsigned, right? Time can't be negative, but it can be, we can also make it negative by using the modifier signed. Okay, if time is negative, it will be considered as I think it's advanced. Yeah, advanced signal. Okay, when you gonna use minus 50, you got the this particular big value. Why you guys got this means, so let me write over here. If time is unsigned, we will get 2 power 64 minus 50 value, that is equal to this value, this particular value only. Okay, 1844. Let me copy this and print over here, paste over here. I'm using the print view. Yeah, so time is unsigned, we will get 2 power 64 minus 50, that is equal to this particular value. And if time is signed, we will get simply the minus 50. Okay, so let me rerun this program. You're gonna see type we are getting the this particular value, and I'm gonna modify. It means the time is unsigned, so the time is unsigned and the time value is x, and time can store 64 bit. So let me use the modifier to change the particular thing. I'm gonna use unsigned, and sorry, it's not unsigned. I have to use unsigned to print the minus 50. So I'm gonna print. So you can able to see I have printed the minus 50. So the question is everything completed? Is there any other type format specifier to print the time? Yeah, there is other format specifier, that is percentile t. So if you're gonna use this percentile t, you can print the minus 50. If you're gonna use 0 before t, then the spaces you can able to see over here, the spaces will be neglected. So let me print. So you can able to see we got the minus 50. So let me remove this sign and see whether we are getting the minus 50 or the 2's complement of the minus 50 when we are going to use the percentage 0d. In case of percentage 0d, we got the 2's complement form, right? So let's see. So we are getting this. Okay. So let's see what will be the default value of time when we use percentage 0d. So we got x. Okay. To print the size, to know the size, you always have to use for any data type, to know the size, you have to always use the percentage 0b. Then only you can able to know the how much the data type is going to, the variable of the particular data type is going to take to store. This is why, because always the size is calculated in the number of bits. Okay, to get the number of bits, we must print the variable the binary format only. Okay, I hope you got this point. Okay, so another point you have to write is format specifier. Additional, we can able to use any format specifier, okay, to print the value of any data type, but we can use percentage 0t to print the time. Okay, along with those particular data types, we can also use the percentage 0t. That's it. If we're gonna use 0 O over here, then you will get in the form of hexadecimal as well. So see, so there is unable to open input file. I think we can't. Let me assign a value. Yeah, so I'm gonna paste over here. O H. Let me use H. I think unable to open input file. Something happened. May print using B. We have to check it. Okay, I thought we can able to print. So yeah, there is a mistake. I have printed the backslash. Okay, so yeah, so let me use the percentage 0h. Okay, yeah, 32. We got the 32, right? We are getting the value in the hexadecimal. So we can also use the percentage 0 O, and you're gonna print the value. If you're gonna print the value, you got the 62. Okay, yeah. So what's the format specifier here is, we can also use the format specifier 0 percentage 0t. We can also, it is doesn't mean we can only, we can also use format specifier percentile 0t to print time along with existed format specifiers. Okay, that's the meaning of this particular line. Okay, if you gonna use int, so let me use the int. Okay, and integer, right? Yeah, and use the percentile 0t to print the integer. So let's see, is it possible or not? Yeah, it's possible. It's possible. Okay, it means I think we can able to use for every data type. So I am also learning new things by this video. So let me use the sumrich. So I haven't mentioned any vector so that we will get the last final digit whether 1 or 0, right? 0 we get it, and let me use the wire, and we have to check like that, so it means we can able to use it. Okay, yeah, I have learned a new thing. So let's remove this. Okay, let's remove this. So you just remember, okay, format specifier equal to percentile 0 t. Okay, remember this point. And yeah, so we have learned about the time. I think almost everything we have learned about the time, right? Everything. So let me clear the terminal. So I think everything is being cleared, right? So let me come to the points to remember to the case of real time. So let me copy this. So these things you can able to know. Now you can able to know, you should know. Because in the interview they may ask what's the default value, all these things only they will ask. So while you going to perform the uh, coding, you will get the, you can able to know where we gonna use. Okay, all these things will be known by you. Okay, so let me do this. Let me comment these things. So I'm gonna comment. Right. Okay. Yeah, code is completed, and now we are going to see about the real time, right? And let me copy this particular code as only. Let me copy this particular. So I'm gonna paste over here, and I'm gonna remove the wire real time and keeping the real time. So in the case of previous one, I have used wire to show, right? So let me change it to time again. Yeah, so I'm used the real time, and let me use the variable what we have used r time, right? We have used the r time. So let me use r time here to differentiate. Okay, to differentiate both the times. Okay, so let the comments be like that. Let us change it. Okay, let us see how many bits can it able to store. Okay, so yeah, let me print this program. I have used percentage 0b to know the default size of the real time. Okay, so but whether we can able to know or not, I don't know. Let's see, there will be magic. Yeah, that's the magic. That's the magic. You got the answer 0. Even if you use the percentage 0b, you got the answer 0. You got the answer 0. Why you got the answer 0? Anyone? Can you guys guess? Because the default value of real time is 0. Okay, so that even if you use the percentage 0b, you got the 0, single 0. Let's say percentage 0, percentage b, removing the 0. So you got the same 0. You got the same 0. Okay, yeah. So let me modify over here real time. By default size we haven't got the clarity, right? Real time value is 0. Some people may say that 0.0. Okay, some people may say that 0.0. Let me use some point 0.1. Okay, let's print it. No, it's 0 as well. Okay, let me use 1. Okay, some people say that 0.0. Why? Because real time is the real values. It is gonna store the real values, right? So that's the thing. So unsigned is, by default unsigned time is x. By default real time is 0. Remember the point. And let's see, by giving -50 again, same case. So let us print using the percentage 0d, okay, to know the value whether we are getting the -50 or its 2's complement uh, decimal number. So we got the -50. We got the -50. Okay, we got the -50. Let me remove this and put the time. Okay, what we gonna get? Let's see. So you got the 2's complement form, but when you use the real time, what you got? What you got? You got the -50. Okay, you got the -50. From this we can able to say what we can able to say. What you gonna able to say? Real time is always signed by default, whereas time is always unsigned. Okay, remember the point. Real time is always signed. Okay, whereas time is always unsigned. That's the difference between the time and real time. Okay, we have got the two differences, actually three, right? Real time value by default is 0, 0.0, whereas real time is always signed, and whereas time default value is x, and time uh, default by default time is unsigned. Okay, we can able to use the percentage 0t. Let's see, can also use it. There is no any problem to use percentage 0t. Yeah, so we got the -50 itself, isn't okay? Yeah, let's see by using the unsigned, okay, modifier over here. So to know the how many bits it going to store, okay, so if we got the same this value, okay, for the case of -50, okay, if we got the same this particular value, then we can able to say that real time is also by default 64-bit. Why? Because if you got the -50, then you can able to say we have used the unsigned, right? Then you can able to say that 2 power with the actual number of bits by default bits minus 50 equal to that value. It means, let me execute, you will get the clarity. Instead of saying I will show, yeah, something went wrong. Okay, I will use the untimed, right? So let me use the percentage 0 day and module item error. What's happened? Let me check. Actually we can't able to use the unsigned, I think so. So actually I have performed um, some some other tools. So in other tools I have seen using unsigned is okay. So in this tool we can able to use, I think so. So uh, it's a tool dependent in the sense it's a simulator or the elaborated dependent. Okay, always some constants will only depend on the tool or the simulator that we are gonna use. So that I think we can't able to use the uh, unsigned, I think so. Let you guys check in some other simulators. Okay, so yeah, so let me prove you this particular thing. By default real time store 64-bit. Okay, let me prove this. Okay, I don't want to guys to tell simply the point. Let me prove. Did you prove it? Yeah, I have given you time, right? So let me prove. So I actually can't able to prove, but okay, let me try. So let me try this. Yeah. So there is a system task. I think so. Let me use it. Okay. Let me use the percentage 0D itself. Okay. Let me save this. Seen all this so long ago. We are getting one. We are getting one only. Let me remove this. The proof is most important. Shouldn't blindly believe other words, other person's words, please. So yeah, let me remove this as well, and let me use the data type. Okay. Yeah. So there is an error. Invalid data type. $4 bits. So there is something wrong. So let us copy this, and yeah, let me copy this and take an integer. Okay, let us take an integer a equal to this particular thing and semicolon, and let me print the integer. So I think we can't able to use the system task in dollar bits system task in this. So let me print. I'm trying. It's also new to me. So okay, then we remove this time rt time. Okay, and let me take again the real time. So I'm trying. I don't know whether I'm gonna prove or not. If I'm not gonna prove, you guys prove it by your own. Yeah, let me. I got the zero. I got the zero. I think there might be something wrong. Yeah, there is something wrong. So I got one. I think there is something wrong. So I haven't proved this point. Okay. Yeah, I haven't proved this particular point. So I will discuss further. Okay, this point. You guys tell me whether you know this particular point. How to print. How to show the prove that the real time by default can able to store 64 bits of data. Time. Yeah. So this is all about this video. Let me arrest this. So in the next coming video, we're gonna discuss some other topics. Okay, thank you guys for your patience. So let me modify this as well. Real time. Let me keep here real time. So this is all about this video. Thank you, and please subscribe and share this video to your friends and like this video. Bye guys. Comment, comment please. Okay. Bye.